This phase project includes ICRISAT Hyderabad, IRI Indian Agriculture Research Institute, NBRI Lucknow, JNU Jawaharlal Nehru University, IHBT, that is MS Swaminathan Research Foundation. Beyond that, we have done also few projects in India. So those all the projects, those are functional and operational across in India. A group of scientists. The interesting part is here a scientific consortia of different scientific, starting from plant physiologists, biochemists, microbiologists, all they are involved with those projects and combinedly doing various research. This is the free temperature enrichment at IHBT Palampur. You can see this is at Palampur. You can see the Himalayan range. You can say this is full of ice, and this is a beautiful location for they have set up the research station. Coming back, the another technology, interestingly, this is called FATE technology, that free temperature enrichment technology is used to create artificially induced uniform temperature in open field condition. The system is based on series of microcontroller with IR heating system. We are using IR heating system for enriching the air temperature, and we are trying to grow plants inside that ring. So the logic control also is very much similar to phase technology. Here we have a ring where you are mounting infrared heaters, and there is a temperature RH and CO2 monitoring and control system. The fate system is also like, no, you can have combined phase and fate together. The same system can be used for both CO2 and temperature enrichment purpose, and the control and automation can be computer control. You can have all those set points done and you can run the system, and you have to have a good amount of power supply, because to enrich a 6-meter fat ring you need to have minimum 100 and 150 infrared heating system. For that matter, 1 kVA or 2 kVA heaters are required, so that you need to have a power generation like no transformer or many other things for the power supply point of view. So we have done various FET system in India, and to just name a few, we have done FET for IRI New Delhi, and they're mostly working on wheat, rice, and few other crops. So we have used many heaters. The top mounted heaters we have used it. So therefore the crops which is close to 1 or 1.5 meter height. So this is again the FET system what we have done it for MS Swaminathan Research Foundation, that is in Chennai. This is typical the controlling system, like know how you control it. You can have all the set parameters and data monitor controlling system. This is the control panel. Basically from here you can have the complete control and automation done. So for the system, this is again the FET system at IHBT Palampur. Again, it's a CSI Research Institute. So FET projects we have done it for IRI, IHBT, and MS Swaminathan Research Foundation. So those projects are still in operation, and we have been supporting them for last many years. So this is coming back to another technology, that is free air CO2 ozone enrichment facilities. So here you want to have the combined effect both for CO2 and ozone together. So this is the schematic. We have done it for environmental science and climate resilient agriculture for IRI. We have developed 6 rings for them, both for ozone and CO2 enrichment studies. What we have done, we have tried to give the ozone supply from an ozone generator to different rings, and different ozone level can be controlled and monitored both CO2 and ozone. And for the CO2 supply, we have used CO2 cylinders. So you can have both CO2 and ozone combined effect studies. So you can have each ring can be like no taken into consideration. You can have from 380 to 700 or 800 ppm CO2 level. Even ozone, you can go up to 100 to 150 ppb ozone level can be controlled and monitored, and that impact of both ozone and CO2 can be studied. So there are some rings can be only used for only CO2, some rings only can be used for ozone, and some rings can be used for the ozone and CO2 studies. This system is developed around 6 years back, and this is a very innovative project. We did it. Uh, One part is there those kind of projects because there is no prototype or things are not available. It is basically a theoretically perception you are converting into a kind of a project. So there are like no you have to have all kind of trial and error method to develop to fulfill the need of this project. So it's not easy. It looks apparently from the system side it is very easy, but the development of logic control, certain changes, and maintaining it for long run and operation also like no 24/7. So you have to take care 24/7 in terms of the functionality of the system. So this is the overview of the project, how it looks like. It's basically this is the discharge of ozone from we are using ducting line for releasing the ozone inside the system. So those things are still in place and are in working condition. This is again the schematic of this project. Now I'm going to talk about a different technology, which is temperature gradient tunnel (TGT) technology, and this is again very interesting project. And we have successfully developed many projects in India. And the TGT is nothing but it's a temperature gradient. When I say temperature gradient tunnel means imagine a situation. There is a tunnel of 30 meter, 40 meter, or 50 meters. What we do it, we try to blow air from one direction and take air out from another direction. And there is an infrared heater that is been placed. So once you blow air, hot air, once it is passing through the other part with air velocity, and because of this velocity, it try to create a gradient atmosphere inside the tunnel. Now the question is, we have mounted every 3 meters for CO2 temperature, for monitoring for humidity also, and there is a gradient atmosphere that has been created inside the tunnel. So now the question is, the same tunnel can be used for the crops seedling stage, like for the screening which temperature or which CO2 level is best for the adaptation, the best growth. That can be screening can be done by using such kind of technology. Those technologies are uh, quite reliable, and we have done it successfully for various research institute. This system is developed for Assam Agriculture University, Division of Plant Physiology, until this is in working condition. This TGT has developed for IRI New Delhi, that is Division of Physics. This TGT is again developed for CRRI, that is Central Rice Research Institute, Co2. Now it is NRRI, that is National Rice Research Institute. Okay, uh, it is for the same application we did it. And this is for the Varanasi, that IIVR, the system still in operation, and they are working on various crops, vegetable crops, for their research institute that is located in Varanasi. So far we have done few projects, that is on CRRI Koto, IRI, IIVR, and AU Jorhat. Again, the interesting part is all those systems all are in working conditions, and we are supporting them, and after sales service warranty we are taking care. Now this is a technology I'm going to talk about, gradient CO2 elongated tunnel technology. And this technology is a very new innovative technology. We did it for ISBT Palampur, and this is a technology where we have created an elongated tunnel close to 60 meters, I believe, 60 meters with various compartments. So we have tried to create an gradient atmosphere by purging air, and we have tried to reduce the CO2 level inside the tunnel. I'll explain to you. This is basically a compartment. You can imagine it is kind of a train bogie. One bogie is connected to a small enclosure, which is like no, and we have tried to purge air from there are from E1 to E7. There are compartments, so you are trying to purge fresh air from one direction and try to take air from another direction. It's a completely airtight environment, so that when you release like no air, it is 380 ppm. So once you grow plant inside this tunnel, so you can see from ET1 to ET7 there is a CO2 deficiency inside the tunnel. What actually happens when you go high altitude, when in basically the Himalayan belt, if you go more higher, the CO2 concentration will be much lower, and the oxygen level also will be lower. Now the question is here, the objective is to have how the impact of low CO2 concentration is impacting the plant growth. So if you are trying to bring the CO2 level below ambient, that is 340 or 300 ppm, so how the photosynthesis level of the plants is been like no changed, and other like flowering patterns of the plants is being changed. For that studies, it's we have developed this project. We took a paper from Elsevier, and from that paper we have developed this system. So again, I'll just come back to this system again. Just I want to come back to the system. This project mostly used for, okay, now this is schematic elongated tunnel. I have not finished this part. So this is the inside of this project. You can see it here. You have all the facilities starting from drip irrigation, so putting watering to the plants. We have the sensor for CO2 temperature and humidity. The entire system is being controlled through computer for data logging, data monitoring, and control purpose. So this is one more project, CO2 elevated bioreactor we have developed for a specific project. We did it for Assam Agriculture University. We have developed many bioreactors where you want to study the impact of azolla rice combination. Like they're trying to develop different azolla variety. Azolla is, that azolla anabina, they fix, there's a mutually like fixed nitrogen, and this nitrogen is helping for the rice uh, plant growth and everything. This is a combined studies, they want to do it. We have developed few bioreactors for them, and this is a CO2 elevated bioreactors. And we have used a CO2 cylinder, as well as uh, at high temperature we have tried to use the copper coil, and we have tried to give CO2 supply to the tanks. This is the elevated CO2 bioreactor for the rice as well as cultivation, and this is the control and automation for the bioreactor. This is the system for Assam Agriculture University, Jorhat. We did it, and this is the controlling X and sensors where we used it, and we have also used AC for controlling the temperature. This is almost 6 bioreactor we have developed, and this bioreactor is both for oxygen, CO2 at temperature monitoring and control option. We have done it, and complete data logging and control system we have provided for this institute. This project is still in operation. It is almost 6-7 years, I believe. We have developed it. It is in working condition, and this is the project. We did it for again various institute. High-tech greenhouse we provide. This is the project we did it for IISS SR, Indian Institute of Soybean Research. This is ICR Research Institute. This is a very big project we did around 3 years back. So again, this is the look. It's a complete temperature control, fully controlled system. We have did it with cellulose pad. So this is the front view of this project. This is the inside, how it looks like. So it has got both light, heating option. It has got foggers, complete control and automation system. That is what we have provided. This is the fan blowers, what we have used it. And this is one more project. We have done it for BRC, Baba Research Center, that is in Mumbai. We have used some cubicles inside the greenhouse, and each cubicle has got both light, temperature, humidity controlling and monitoring option. This project we have developed this year, that is 2020. We have completed this project, and it's a very big project, and it took little long time for us to develop this system. Now this system is operational, and it is almost like we have used 10 plant growth chamber kind of thing. You can use it for various research project for different crops. So it has got both light, temperature, and power monitoring option, and also the humidity, and you also can control the temperature. So this is the PGM unit for BRC. We have also given few working time plan growth monitoring and control option for various research institute. This is for IISS, Indian Institute of Soil Science, Bhopal. We have given a big plant growth chamber for the research purpose with RGB light option. So these are few plant growth monitoring system we have given for TNU, Tamil Nadu Agriculture University, Bharatiya University. We have done it. We are also doing various projects on aeroponics and hydroponic system. We have supplied few systems for IIT, Kharagpur, and Kerala Forest Research Institute. We are working also for few projects for different research institute, and this is probably one of the interesting things in agriculture that might be needing the world most. It can be used for various applications in small or big scale. This is the aeroponic system we have developed for KU, that is Kerala Forest Research Institute. This is for Forest Research Institute Kerala. This is weather station. We have supplied various weather station along with our phase system to various research institute, and we are also working on lab scale biodiesel unit. So we have not executed, but we have the technology. But if we get some kind of collaborative project, we are ready to work with some research institute in coming days. This is a typical aeroponic system. This is the hydroponic system. This is the eddy covariant system. So I just want to tell you, beyond that also we have been doing many projects on climate change research. So again, those projects are all in a working condition. Recently we did some project for University of Dubai, and it requires a lot of effort to do such kind of project, and hope in near future we want to also do few more projects. We are doing also project for BRC. We have developed recently one big plant growth chamber. We did recently a big project for ECRISAT also, to temperature gradient tunnel, few OTC work we did it for Hyderabad University. We have also developed few system at Himalaya, very high altitude where there is no power. So they are working on solar energy. So we are operating system with solar energy at north some universities. So again, I want to say that our engineers, they are working hard to develop such kind of system, and we always try to give a system which is having a lot of technological inputs, and very quality projects we provide for the our customer, and we support them wholeheartedly. So we have a beautiful website and very informative. That is, our website name is www.genesisindia.net.in. We are ISO 9001 2008 certified company. Probably we are the first company in India that is working only on climate change studies, simulation, and modeling. We have done close to 60 projects across India and abroad, and in future also we are hoping to do very good projects with various research institute. We have worked close to 2000 research scientists, and we are in touch with globally many research institute, and we are always